Hello everyone, this is my submission for the Chainlink Hackathon. I created a decentralized betting escrow powered by smart contracts, Chainlink keepers, and Chainlink data feeds. The inspiration for this project was I was on Twitter and I noticed that Duquan, the creator of Terra and Luna, made a bet with a couple anonymous traders. They used a third-party individual that goes by Kobe to hold all of that money. It ended up being, like, the total pot ended up being $22 million, and that's a lot of trust to put in one individual. Given that these are ERC20 assets, we can use smart contracts instead of one person, so I created a proof of concept to show how it's feasible. So, without further ado, take a little look at the code and a little bit of the demo. First up, we have the code. The code follows a factory pattern, so all of the escrows that are created go through this contract. When they are created, they take the following parameters: the asset price feed, which is the Chainlink data feed for whichever asset they're betting on; the wager, which is how much each side is going to put up; the anchor price, which is the high or low point. In the example the inspiration, Duquan was betting that the price of Luna would be trading higher than $88 in 1 year, and the anonymous traders took the other side. And obviously the anonymous traders have won this bet, so in about a year they'll be paid out by Kobe. But in this case, we have, they could have done it with smart contracts. In this way, Duquan could have deposited his money here. It would have verified that there isn't someone who already took the bull side and that the value matched up to the wager. And then the bear side, same thing, just vice versa. Where here we have the contract balance, basically just how much Ethereum is in the contract. This is just for Ethereum right now, but it could be extended to any ERC20 asset. And then we have the send winnings, and this takes all of the ether that's stored in the contract and sends it to the winner at the end of the payday, when the bet ends. We have the keeper compatible functions. The first one being check upkeep. The check upkeep function checks to see if the current timestamp is greater than the payday timestamp. If so, then it performs the upkeep. When it performs the upkeep, it checks, it verifies that again, and then says, is the latest price from the Chainlink data feed greater than the anchor price? If so, send the money to the bull, or equal, greater or equal, so the tie goes to the bull. If it's lower, then send the money to the bear. But yeah, that's the code. I'll go quickly to the UI. Right here, this is how you would create an escrow. You can get that from the Chainlink data feed. And actually, in the interest of time, I actually have the values hard-coded, just stored in state. So when it is created, it pops up on mask, and then you can see the parameters line up. In this case, the parameters aren't here, they're just hard-coded. You hit confirm, it sends off, you have a link to the transaction hash, and then a link to the register it. So this is how you register the upkeep. You would go to the transaction, you would see that, okay, it's been created, the new contract. You go here, this is the new escrow contract. You would take that, you'd put it in here to make sure that the keepers are watching, and you fund it with link, and when the payday comes around, the keepers will pay the winner. With the UI, this part was completed. The following was not. It was supposed to show all of the existing bets in the escrow account. So you can see all of the escrow factory. These are all my test ones here. And then it creates an escrow contract that looks something like this, where the bear can deposit, the bull can deposit, and then the keepers can perform upkeep. That's basically the project. You can see the code on my GitHub. Thank you for listening, and have a nice day.